A quick brief on velocity that we were discussing the other day. Okay, why I'm taking time? Because if you have to understand this for your grade 11 and 12. Okay, grade 11 rather. Velocity, what all did we study? Vector quantity. It is given by what? It's a vector quantity, is the ratio of displacement over time. Okay, it's the ratio of displacement over time. You can also call it as speed in a given direction. So since velocity is a vector, velocity will have a magnitude. Okay, quick discussion, participate in these, children. You all have studied it last. Magnitude, it will also have something known as direction. Okay, this is one thing that you studied. The SI unit for velocity would be meter per second, but try writing it as ms minus 1, right? And how do you change velocity? Okay, right, 1 minute. If you want to change velocity, say, if you want to change velocity, then you can actually change by either changing the magnitude or changing the direction. We spoke about all these things, people traveling in opposite direction, two aircrafts traveling in the straight direction, so you can change it. Apart from that, we also studied something known as uniform velocity. So uniform velocity will be defined by, what are the criterias? You should have a moving body, number one. Think in this manner, don't mug up the definition. Moving body, the moving body should be moving in a straight line, and when it moves in a straight line,
in equal intervals of time.
No, equal displacements. Yaad mat karo, don't memorize it. Equal displacements in equal intervals of time. Equal intervals of time. Everything, if you follow a mechanism, the thing comes absolutely right. Many things we don't understand. Like I'll tell you, the other day, we keep on exercising. You lift weights, dead weights. You lift the barbell when you lift. The instructor came and told me one thing, and I really liked it. What he told is that, sir, you are lifting the weight. I said, yeah, that's what I'm supposed to do. He says, no, your arm should not bend as you are lifting it. You should push the ground and automatically the arm should move up. That's actually physics. If you try and see, when you lift the barbell from bottom, your elbow should not bend. That means you're lifting the weight. So aise yaad mat karo, don't say equal intervals. Equal displacements in equal intervals of time. And there's another word, no matter how small the intervals are. How small the intervals are. Okay. How many of you are reading the textbook back at home? How many of you feel that after the class, don't do that after the class is over, my job is over? That will never help you, okay? Now, we will go to problems of velocity, but I will just make you write two things and then we will take up problems, okay? One of the problem of velocity, very easy, which may come, is only using this particular formula. So there's nothing great that you have to do. So there's no much bit of understanding. Another is, you may also get a term called average velocity, and this I'll cover up a little bit later once I cover up acceleration. So average velocity multiplied by time will actually also give you displacement. Just like distance equal to speed into time, its displacement is equal to velocity into time. And one thing you guys should have in your memory, okay? One thing you should now have in your memory, that whatever you are studying in class 9 about motion, if this is your vehicle in grade 9, your vehicle is always moving in straight line. This thing should be in your, just like at the back of your head, always in straight line. You are only covering displacements, obviously from point to point. There is no question of distance. Hence on, there is no question of distance. You are only covering displacement. You are moving in straight line, and all you will be dealing with is velocity, not that much with speed. So you may ask, sir, is speed out of syllabus? No, speed will be there, and speed will come only for two parts, speed and average speed. That's all. They may ask you one problem on speed and average speed, nothing more than that. But this is what should be there in your mind. Your vehicle is moving in a straight line, and your vehicle always covers displacements, and it has velocity. And speed is not there. You're not studying about speed in this. Okay, this much understood. Let's take up another topic and then come to problems. Okay, so we have understood this. Now, remember one more thing. I will come to this a little bit later. Okay. Out of this, you have got to know this fellow. You have got to know this fellow. There's these two. Nothing more than that. What are they? I'll come to it later. Suvat. Yaad rakhna hai hamesha. Suvat. Okay. Suvat CBSE mein nahi bolte hain. If you go abroad, they'll always use, this is a Suvat problem. So what is a Suvat? I'll tell you. Our next topic of discussion would be acceleration. Acceleration. Right? Okay. This is our next topic of discussion. And pay utmost attention in this topic. यहीं पे सबसे ज़्यादा गड़बड़ी बच्चे करते हैं. So we learn distance, we learn displacement, we learn speed, we learn velocity. This is our fifth topic of acceleration. If you look at the bottom of a driving seat in a manual transmission vehicle, you will find 3. In an automatic, you will find 2. Okay, 2. If it is a manual transmission, you have a clutch, you have a brake, and you have an accelerator. If it's an automatic transmission, you have brake and accelerator. All you're going to study about is this pedal now. In America, they call it the gas pedal. Press the gas pedal. We call it the accelerator. इसको दबाने से क्या होता है? What does it happen? The car moves front. The speed increases. Yeah. But you'll stop yourself from saying speed because you think speed is no more in the chapter. The speed increases for you because you don't travel in displacement. You can't travel in displacement, right? It's very difficult for you to travel in a straight line. So how you travel in a zigzag manner. So for you, right, the speed increases. So acceleration's definition, the first definition of acceleration. Okay. Now how physics goes in this chapter is, first you learned displacement. First, you learn displacement and the ratio of displacement over time. What did you call it? Displacement over time was? Velocity. Velocity. Very good. Velocity. That is actually change in displacement over time. Okay. Change in displacement over time is velocity. So I can also write it as change in displacement. Change in displacement. Change in displacement over time. Change over time elapsed is also known as velocity. Now, little bit high level mathematics I'll put here. The word change in mathematics is denoted by the word Greek letter delta. Delta means this is delta. This is capital delta. There's a capital delta and there is a small delta. Small delta is like this, will not work. Delta means what is the change in temperature in Hyderabad since yesterday? Delta T, we'll call it. Change in temperature is delta T. Between any two quantities known as delta. So you can write your velocity little bit higher level as delta S over delta T. What do you mean by that? At 8 o'clock, okay, my displacement was 40 meters, and at 8:00:10 seconds. Okay, this is 8:00:00. My displacement is say 80 meters. In 10 seconds, I've gone this. So this is known as my S1, the first displacement data, and this is T1. Okay, I should write it the other way. Else you will get confused. So this is S1. This is T1, this is S2, this is T2. So what is your delta S? Always final minus initial. So final, that will be S2 minus S1 over T2 minus T1, right? Or sorry, not delta. Delta S is this. Sorry kids. Your delta S would be S2 minus S1. What is the value of S2 minus S1? 80 minus 40. Which is equal to 40 meters. So this is your change in displacement. And if I ask you what is the change in time, delta T, you will say 8:00:10 seconds minus 80000. So you'll say it is 10 seconds. Can you now calculate? We are doing the mathematics in a reverse manner. Okay, I'm sorry. Can you now calculate what is your velocity? You will say, sir, it is delta S by delta T, which is equal to 40 by 10 equal to 4 meters per second. Have you understood this mathematics? Nothing great? Okay. Delta S by delta T, change in velocity over change in time. All right. So that is known as velocity. Ye change jo word hai na, this will now start haunting you. So how do I now define acceleration? So if later children study this, they'll get confused. So let me cut off acceleration from here. So I'll just move this word now out here. Okay. First, the analogy how you should study. First, you understood displacement time. Then you brought a quantity velocity, which is displacement over time. Now you will bring a quantity called acceleration, which will be velocity over time. Very interesting. How will I tell it as? How will I write this in our delta language format? In our delta language format, we'll write that acceleration will be delta V by delta T. Change in velocity by time taken. Let's now understand. Here's our definition. What is acceleration? Acceleration is rate of change of velocity. Change of velocity. Pehle iska, let's try to take the feel of it. What is rate of change of velocity? Okay. Rate of change of velocity. Whenever you hear of this word called rate, I told you think of time. That means velocity over time. Velocity over time. This is theory part. Now let us understand this thing. Okay. To understand this thing, we'll again take a nice little example. Let's say this is time axis, right? That's time axis, right? And our measurements are starting from 808000100. Okay. And thereafter we are moving 1 second each. So this is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, and let's say this is 6 seconds, which will be 8080006. Everyone has understood this thing, right? This is time. Okay. At this moment, this is my vehicle. Okay, this is my vehicle. And my vehicle is having a velocity of, say, 2 meters per second. 2 meters per second. Have you understood? Right? After 1 second, suddenly the velocity of this vehicle has become 3 meters per second. Please understand, this is a little bit challenging concept. 3 meters per second. At the end of second, the vehicle has picked up 4 meters per second. At the end of third second, it has gone to 5 meters per second, 6 meters per second, 7 meters per second, and at this it is 8 meters per second. My first question to you, is the velocity uniform or non-uniform?
Uniform.
Uniform. What is the definition of uniform velocity? Let's plot uniform velocity. We have to use graphs. Uniform velocity. Uniform velocity means what? बोलो बोलो शेष रुकना नहीं है आज समझना है हमें.
The uniform velocity is distance traveled in.
Forget those things. Uniform. The color of your shirt is uniform. What does that mean?
There are patterns of equal colors.
Uniform means the color is uniformly spread. There is no region of dark patch and light patch.
Light patch.
Right? So it's, what do I say? The color pattern is constant. Yes. How will I plot uniform velocity? Tell me what is uniform velocity? Sir, there is an ant. There is an ant, and this ant is going at uniform velocity. It is at east, and say it is going at 20 centimeters per second, or much more slower than that. Let's say the ant is going at 1 centimeter per second. Is it uniform velocity? Yes, uniform velocity.
Yes.
Uniform velocity means your direction. Now be very, very critical when you're answering me. Uniform velocity. Velocity is a vector. If sir has said uniform means its magnitude cannot change its direction. Magnitude is not changing, direction is not changing. So how should the plot of uniform velocity look like? You tell me.
It should be constant in a straight line.
Straight line means? Explain. Parallel to x-axis, y-axis, slant. Be particular. Straight line means what? Chodo mat na. Uniform, the temperature of Hyderabad is 30 degrees right from morning till night. So how should the graph look like? Shaurya bolto? Kahan gaya? Graph kaisa lagega? The temperature of Hyderabad is uniform from morning. Say this is morning and this is night. Our temperature today was at 30 degree only. How should the graph look like? There's nothing to think here. There's nothing to think.
Go
Straight
in a
line parallel
horizontal
to
line.
x.
Who said that? Somebody said parallel to x. Who said that? Yeah, Zoe. Yes, it's a straight line parallel to x-axis. So the velocity is uniform. What is the velocity of this ant? 1 meter per second. So how should that graph look like? The graph will look like this. Say this was the velocity, whatever was the velocity, say v meters per second. So throughout the time, the velocity is this. Now look into the scenario I gave you. What was the velocity at 8 o'clock 1 second? What is the velocity? बोलो ना बाबा, चार्ट देख के तो
3
बोलो.
8
meters per
meters per
second.
second.
What is the speed? What is the velocity?
8
3
meters
meters
per second.
8 o'clock 1 second, I'm saying.
3 meters per second.
3 meters per second. What is the velocity at 8 o'clock 4 seconds?
6 meters per second.
Do you think the velocity is constant?
Yes.
You
Yes.
are still not interpreting. Just pay attention. Look at this graph. This is the time at 8 o'clock 1 second. This is the time at 8 o'clock 4 seconds. The velocity is constant. Do you see that pattern here? What is the velocity at the first second? You tell me. 3 meters per second? What is the velocity at third second? 5 meters per second? How can your graph come straight then? Your graph will be at this moment, your velocity is this. Next moment, your velocity is this. Next moment, your graph will rise up. How do you expect the graph to be straight? Apply head, huh? From here, it cannot be rattu tota mein nahi ho sakta hai physics. Have you understood what I'm trying to say? You have answered me, velocity is uniform. You're still unable to crack that it is not uniform. Where is the velocity uniform? Go to the definition of uniform velocity. Uniform velocity means equal distances, equal intervals. That will not help you here. Shall I tell you what is uniform velocity? Uniform velocity hone se, it should have been 2 meters per second here, 2 meters per second here, 2 meters per second here, 2 meters per second, 2 meters. Uniform, the velocity has not changed throughout the last 10 seconds. Then only I'll get a plot like this. How many of you agree and have understood what I'm trying to say? Right. If you say that the velocity, but in my case, is the velocity uniform? No, the velocity is not uniform. Kahan uniform hai? Dekho na. First second mein 3 meters. Second second mein बढ़ गया. Can you narrate this scenario by a noise of the engine? See, you may laugh at the way I'm teaching you. You may laugh now. But इसी को कहते हैं physics का feel. You know what is uniform velocity? How the car will sound you? How will the car sound? It will go like this. And if it is here, what is happening? The velocity is increasing. यहाँ कैसे जाएगा? ऐसे. Because every second the velocity is increasing. No, don't laugh. Because if you understand this field, then only you will be able to appreciate the scenario. Otherwise, you in CBSE people don't do graphs. In Cambridge and IB, they do graphs. In CBSE, the graph is much less. So you will get all up, latak jaoge jab ye problem aayega. Try to take the feel. My velocity was at 8 o'clock this. This is like a rocket launch. ऐसे जाएगा. The velocity is increasing. Every second the velocity is increasing. Have you understood? Shall we now apply the knowledge that we learned? Let's take this as T1. Let's take this as T2. Can you tell me what is the delta T here? Sir, delta T is T2 minus T1. How much is the value? 1 second. Let me take this as S1, or let me take this as V1, and let me take this as V2. Can you calculate what is delta V here between these two? What is the delta V? Karo, participate karo na,
V2 minus V1.
minus V1. So what should be the velocity change here? Delta V? 1 meter.
meter per second.
Every second the velocity is getting added up, my dear. The vehicle is racing. And the first thing I told you, we are studying acceleration means on the right leg of our, we are pressing the accelerator pedal. If you press the accelerator pedal, how can you have uniform velocity? Dekho, I will try to prove many ways in which you will now repent on the answer you gave. I'm not angry on that answer of yours because you are learning. But the repent feel should come. Arey, main aisa galti kaise kiya? Sir is teaching accelerator. If I press accelerator, acceleration happens. How can velocity be uniform? If you press accelerator, does the speed change or not? You tell me. Changes. Bus. Magnitude has changed. How can you have uniform velocity? You can't have. हो ही नहीं सकता. Let's look here. Let's look here. This is V2, this is V3. Can you tell me what is the delta V here? Another 1 meter per second. Out here, how much is the delta T? Another 1 second. Acceleration is rate of change of velocity. So from tomorrow, if this is you and this is your year, and you hear about the word called acceleration, when you hear about acceleration, this will have impact on second chapter also. You should immediately say, immediately velocity is changing. Okay? That's the first thing you write. Hear about acceleration, velocity is changing. Number two, what will we write? That velocity is not uniform. हो ही नहीं सकता uniform. कैसे होगा? If it is changing, it cannot be uniform. It is not uniform. How many of you have understood this? Clear? Clear? If you hear about acceleration means velocity has changed, right? Let's now talk about so what is acceleration? Acceleration is, so if we write it as a formula, if we write it as a formula, we'll write acceleration is defined as change in velocity. So people will write it as velocity over time. Actually, the word is change in velocity, not velocity. Change in velocity over time. So let's look at the SI unit first. Okay, let's look at the SI unit. Come on, try the SI unit with me. Try karo. What is the unit of velocity? Meters per second divided by time, another second. Sir, I don't know how to do this. No issues. Meters per second divided by second. We'll do baby steps. Meters per second into 1 by second. Meters per second square. ms minus 2. Obviously, velocity is ms minus 1. So acceleration is ms minus 2. How many of you could not follow? Okay, yahan tak? SI unit done, right? So if I ask you that there is a horse, and the acceleration of the horse is 1 meter per second square. What do you understand? A horse is said to have an acceleration of 1 meter per second square if its velocity increases at the rate of 1 meter per second every second. Are you understanding? If the horse started with something called, say, 40 meters per second, say, for example, just maybe it's too high. Okay, let's make the horse have, say, 10 meters per second. This is the first second. Tell me, second, what should be his velocity?
11 meters.
11 meters per second. Where is the velocity uniform? It's not uniform. The horse is galloping fast. Speed बढ़ जा रहा है उसका. You get the feel of it. Constant velocity means constant. Like we were talking the other day about cruise. If you do cruise, what do? You set the car at a particular velocity and move your legs from the accelerator in an automatic transmission car, and you find that the velocity is constant. Out here, we are accelerating, right? We are accelerating. Okay? समझ में आया? Acceleration is rate of change of velocity. Now, this will bring us, open up Pandora's box. What is the Pandora's box? The Pandora's box is something like this. I told you that the moment you hear about acceleration, the first word should come to your mind is change. Sir, what is changing? Velocity is changing. Means, if you want to calculate acceleration, you should have two datas of velocity. Then only you will have that factor called delta V. There should be two datas of velocity. Okay? One data we will call final velocity. Okay? And the other data we will call initial velocity. That's what I was trying to tell you as V2 and V1. So what is my change in velocity? Let's say change in velocity. So what is the change in velocity? You apply, sir, you made us some higher mathematics, delta V. What is delta V equal to? Sir, V2 minus V1 was a better way to remember it. Sir, final velocity minus initial velocity. So the moment acceleration comes, it will bring two kids with it. Who are the two kids? Initial velocity, final velocity. Agar ye dono nahi hai, then there is no acceleration. What is sir trying to say? Sir is trying to say that delta V is equal to V2 minus V1. And in this scenario, V2 is equal to V1. Very good. Then delta V is equal to 0. No, velocity is not changing. No acceleration. Car is going at a cruise control. Like this. So let's visit our graph again. In this graph, what would be your comment on acceleration? 0.
Sir, I have a doubt.
Yeah, please.
Sir, here in this example, if like the time graph is showing a straight line, but increasing, wouldn't it be uniform?
Means the time graph, I didn't get you. Come again, Aparna.
Like from 0, it's going to 1 and then to 2, like increasing steadily.
Yeah,
As in
now
a
I'm
straight line.
taking the case of a uniform acceleration case. Okay, this I'll come to that. Just hold your question for 1 minute.
Yeah.
Okay, so let us first understand acceleration as a concept. If you have acceleration, this thing you need to remember throughout. If you have acceleration, you will have a change in velocity. And if you have a change in velocity, there will be a final velocity and there will be an initial velocity. And the difference of these two will be the change in velocity. In physics, we don't call them as V2 and V1. We have separate names for them. This is denoted by V, small v. This is denoted by U. Again, initial velocity is U, final velocity. So can I now write the formula for acceleration? Acceleration is delta V, change in velocity over change in time. So many people write it as delta V over T, means delta T has been taken as T. Same, not an issue. So let's write what is delta V? V minus U by T. Final velocity minus initial velocity over time. This time is the time that has elapsed. That is the change in. Clear? So far clear? Okay. Unit will be meter per second square. You can write it as ms minus 2. All right. Now, if velocity is uniform, that means if I take a time chart and I take a time t1 and I take a time t2, my velocity here was v, it should be v here also. Uniform velocity, right? Uniform velocity. So what is the delta v out here? 0. If delta v is 0, then what is a? Delta v by t, 0. In a uniform velocity, there is no acceleration. I mean, just try and think. If you know a little bit about driving, if you want to follow uniform velocity, can you press the gas pedal? You can't press it. Can you release the gas pedal? You can't release it. You have to hold it constant. Right? That's why people say when you are driving on a highway for a long stretch, there is no activity. You tend to drowse because neither you will be braking. There's no movement of your legs and all. You're driving at a constant speed. So many people say, pair hata ke, you keep a stone on the accelerator because it's constant speed. There's nothing. You're on a toll road. So you can't release your accelerator, neither you can press. Okay, sir, I pressed it immediately. So, sir, I was going at a velocity of 40 over time. I pressed it. Very good. Why did you press it? Because, sir, the velocity limit is 800. I realized I can now jump up to 80. Okay, I jumped up to 80. But then, sir, I did not increase. So I'm going like this. It's a step curve. It's a step curve. Did you understand? This velocity was 40. This velocity is 80. However, here there is acceleration. Why acceleration? Socho. Beautifully try to get it in graph mathematics. Mein samjho. You see, this is a different value. This is a different value. Is there a change in velocity? Obviously, there is a change in velocity. This is the change. This is the change. What is the velocity here? 80 meters per second. What is the velocity here? 80 meters per second. What is the velocity here? 40 meters per second. Have you understood?
Sir, but what if it goes back to 40 meters per second?
Okay, you want to come back to 40, that will come down to that. It's a negative acceleration. That is called retardation. We'll come to that. That's a negative. Okay. So have we understood acceleration as a whole? A quick summary on acceleration before we take acceleration more deeper. Okay. Acceleration. Acceleration in literature, English also means velocity should increase. Velocity should increase. As per literature also, okay, as per literature, velocity should increase. Given by delta V over delta T, okay, and this can be written as V minus U by T. What is V? This is what is important for you in grade 9. In grade 9, this is important. Grade 11, you learn by this method. But anyways, you can learn from now itself. This is known as final velocity. This is known as initial velocity. I will first address Sanvi's question, then come to Aparna's question. Initial velocity, okay, and this is time. So what does the unit become? Meter per second minus meter per second. So it will be a meter per second on the top, and time. So it is a second. It becomes meter second minus 2. Clear yahan tak? Okay. Now, Sanvi raised a question. I said that I started with the initial velocity of 20 meters per second, and then I increased my velocity to 50 meters per second. What is the delta V equal to? Sir, the delta V is always final minus initial, always final minus initial. Final velocity minus initial velocity. Sir, it has come to V minus U, which is 50 minus 20, which is equal to 30 meters per second. Got it? Sanvi, now pay attention. Your query will be answered. This is my iteration 1. On iteration 2, I am on the ORR, and right now my initial velocity is 80 meters per second, and I see that the toll gate is approaching. So my final velocity has become 10 meters per second. Samajh mein aa raha hai? Sanvi, your case now, 10 meters. Delta V will be what? As I told you, always final minus initial. So let's do final minus initial. Karte hai chalo. So final velocity minus initial velocity. Pratiki madam, 10 chal raha hai ki nahi? V minus U, 10 minus 80. It is coming negative 70 meters per second. You get it? Now let me say that the time for this, okay, I should have a delta T figure also. Delta T was 10 seconds in this case also. Delta T was 10 seconds in this case also. So let's calculate the acceleration in this case. Acceleration is delta V by delta T, which is equal to 30 by 10. So we will say it is 3 meters per second square. Every second, the velocity is increasing by 3 meters per second. So if I was, you can calculate and exactly go. How many seconds did we have? 10 seconds. Children, let's do this calculation. How many seconds did we have? 10 seconds, right? Let us write the 10 seconds. 1 second, 2 second, 3 second, 4 second, 5, 6, 7, 8, 9, 10. I started with case number 1. I'm still on case number 1, not on Sanvi's case. Case number 1. I started with what velocity? Tell me, Sanvi, I started with what velocity? Look at the initial velocity.
20.
20 meters per second. What is the acceleration you calculated? 3 meters per second square. Means 3 meters. What does this mean? This means 3 meters per second every second. Every second. So in the second, what should be my velocity? Come on. If you answer me this, I will understand you have understood. What should be my velocity?
Can you repeat the question?
How much?
Can you repeat the question?
My question is, I started with 20. Now see, I started with 20. I rose up to 50, and all these things I did in an interval of 10 seconds. I then calculated my acceleration, and I found that the value of acceleration is 3 meters per second square. Correct? 3 meters per second square means the velocity is changing at 3 meters per second every second. Prati second, 3 meters per second change ho raha hai, right? I started with, on the first second, this is my first second. My velocity is how much? 20. My velocity is 20, right? This is that 20. Got it? Second, what should be my velocity? If I'm
23 meters per
23
second.
23 meters per second. Very good. Next, what should be my velocity?
26 meters
26
per second.
meters.
Then
29,
29,
29,
32,
32,
then
35, 35,
then
38,
38,
41,
40,
44,
44.
44, then
47.
47. 1 to 10 means
47.
there should be one more second here, 11 second. What should be the velocity here?
50.
50. What was my final velocity? 50. As if expert. आ गया?
Yeah.
By the time you reach the 10th second, 1 to 11 is actually 10 seconds interval. Okay, please understand. Little bit of fun here. If you want to make 3 slices out of a cake, how many times will you run the knife? Sir, 3 times. Idiot. That will give you 4 slices. 2 times only. If you run the knife 3 times, then you will get 4 slices. Just think 1, 2, 3. Sir, 1, 2, 3, and one more 4. If you want to slice a cake for 3, then you run your knife twice. Okay. So 1 to 11. Does this make it clear now? What is the concept of acceleration? So how will the engine sound like? ऐसे जाएगा पूरा. It won't be. No. Always have that feeling. Rocket just launch hota hai, the way the rocket is launched. Clear? Right? Now let's take the next case. In the next case, let's do for the next case also, right? Next case, let's again make it first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. 10th, there are 10 intervals are there. 1 interval, 2 interval, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, it's gone to 11 seconds. Right. Fine, it's okay. Now, how much is the acceleration here? Calculate delta V by delta T. Tell me the value of delta V. Negative 70. Delta T, 10. So it should be how much? Negative 7 meters per second. Right? Got it? You should have written it as negative 7 meters per second square. Okay, tell me, at the first second, what was my velocity in this case?
80.
80. My velocity is 80. 80. Second, what should be the velocity?
73,
73. Because yes, very good. So what is happening? Gradual braking is happening. Gradual braking is taking place. Then
66.
66. Then
59,
59. Then
52,
52,
then 45.
45,
45. Then
38,
38. Then
32, 38, 38.
31, 31,
31. Then
24,
24.
31.
minus 7 na to 24,
24. Then
17,
17. Then
10.
10. Again, final velocity is 10. Initial velocity was 80. What is your acceleration? You see how the velocity is changing here. Between your delta T is equal to 1 second. Your delta V is equal to minus 7 meters. Aha. Minus 7 meter per second. For every second you're coming down. And I told you in literature, acceleration means positive. So here, what will I write it in terms of acceleration? Okay, I will write in terms of acceleration as negative 7 meter per second square. Whenever acceleration is negative, physics gives it another word which is known as retardation. Retardation. He's retarded. Piche chal raha hai, retardation. But when you will write the value of retardation, at that time you will write A as not minus 7 meters per second square. This is again a catch. If you want to write it in terms of acceleration, you will write 7 meters per second. If you want to write it in terms of retardation, you'll write it like this. Okay. How to understand this concept? Simple. If you make profit in a business, it's a healthy sign. Suppose Shaurya makes a profit of 10 rupees in business. He shows this as P equal to positive 10. Next year, Shaurya has done a loss of 5 rupees. So either he can write as loss equal to 5 rupees, or if he still wants to show it as profit, he will write as minus 5 rupees. It's that same convention out here. Acceleration, bole to, acceleration means velocity should increase. That's why I'm writing minus. It is increasing at a negative rate. Retardation means पीछे ही आ रहा है, right? Positive acceleration is negative retardation. Simple, understood? Positive acceleration is negative retardation. The child is not retarding, the child is going ahead. So his retardation factor will be negative. The child is accelerating, positive. The child is retarding, पीछे आ रहा है. इतना समझ में आया?
Sir,
Now,
if you take it
yeah.
in terms of retardation, then acceleration should be negative, right?
Right, I'll just give you one example. A problem में बोलेगा acceleration equal to 2 meter per second square. Forget everything. आपके दिमाग में क्या आ रहा है? Velocity is increasing or decreasing?
It's increasing.
Accelerator means accelerator. गाड़ी का accelerator positive. So here straight away velocity is increasing. If you want to write it in terms of retardation, what will you write?
Negative 2 meter per second.
Negative 2 meter per second square. But we don't write this at all. What is the reason of writing this? There's no reason of writing. Acceleration equal to negative 2 meter per second square. Velocity is falling down. So instead of, if you are not fine to write this word, like this sign negative, you can write it as, the question will give you as retardation. The question will say a car is undergoing retardation at 2 meter per second square. But when you do the problem, you will have to write A is equal to negative 2.
Right.
Here about accelerated retardation. So I would write it like this, that this is your year. When you hear about retardation, immediately what you should do, A is negative. Because your formulas are based on A. Okay. Now coming back to Aparna's question. Aparna, the reason I took my time axis in this manner was, I was trying to show 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Okay. So what is this basically? Equal intervals of time. I just wanted to be a little bit lazy, not make two different drawings. And how much was the velocity changing? Every time the velocity change in velocity was 1 meter per second, right? This was what was in our example. So is there an acceleration? Yes, there is an acceleration. How much is the acceleration? 1 meter per second square, right? This is 1 meter per. Such type of an acceleration is known as uniform acceleration. A body is, now write down, uniform acceleration. A body is said to be in uniform acceleration if it travels in a straight line. Everything will first start with that word straight line. If it travels in straight line and its velocity, now you make your own definition, increases at a uniform rate, or increases by equal amount. You can write increases by uniform rate, or you write if its velocity changes by equal amount in equal intervals of time, no matter how small the time intervals are. Have you understood? First, understand it. A body is said to be in uniform acceleration, or is said to move with uniform acceleration. Uniform acceleration does not mean uniform speed. How is the engine sounding? Ah, that's uniform acceleration. That is not uniform velocity. Many children confuse that. A body is said to move with uniform acceleration if it travels in a straight line, first criteria, if it travels in a straight line and its velocity changes by equal amounts in equal intervals of time, no matter how small the time intervals may be. No matter how small the time intervals may be. Right? And if nobody asks you to define non-uniform acceleration, but still you can define non-uniform acceleration. Body is moving in a straight line, but its velocity is changing by unequal amounts in equal intervals of time. So how should the engine sound like? It will sound like this. Kabhi बढ़ रहा है, कभी घट रहा है, कभी बढ़ रहा है, कभी घट रहा है. Non-uniform. Right? So that is called non-uniform velocity.
Can you repeat the uniform acceleration?
Once again, uniform acceleration.
A body is said to be in uniform acceleration if
A body is said to be in uniform or said to move with uniform acceleration if it travels in a straight line. By
Okay.
straight line, you are defining the displacement part. Then only velocity will be born. Acceleration is the grandchild of displacement. Just try and think. First displacement, Displacement ka bachcha velocity, velocity ka bachcha acceleration. Okay. So if a body travels in a straight line, first of all, and its velocity changes by equal amounts in equal intervals of time.
Equal.
Amounts in equal intervals of time.
Equal intervals.
Of time. Yeah. Zoe, please go ahead.
Is there a notation for retardation?
We don't have any notation for retardation. When they say retardation, you are supposed, notation is always A, Zoe. A will be +2 if they write acceleration is, if they write retardation, you will write A equal to -2. That's all. Okay. Sure, you are clear, Avi? A body is said to be in uniform acceleration, or said to possess uniform acceleration, said to move in uniform acceleration if it travels in a straight line. वो पहले ही बोलना होगा. And then its velocity increases by, increases मत बोलना, changes, because uniform acceleration can be uniform retardation also. Like in our case, we found a uniform retardation. We also found a uniform acceleration. ठीक है?
Thank you.
Right? And if it is non-uniform, what would you say? A body is said to have non-uniform acceleration if it travels in a straight line, means there has to be displacement and velocity, but the velocity is changing by unequal amounts over equal intervals of time. Means in that case, how it will be, Aparna? Here it will be suddenly 2 meters per second. Next 1 second, it may be 1 meter per second. Next, it may be 5 meters per second. So the change is not uniform, right? So you tell me, in our daily life, we all accelerate. Do we accelerate uniformly or non-uniformly?
Non-uniform.
Non-uniformly.
Uniformly means, are you understanding? If cow, goat comes in front of us, we'll straight away bang them. Because our job is, sir, we started from Pebble City, 10 meters per second. Next 1 second, 11. Next 1 second, 12. After 10 seconds, we are at 22 meters per second. There are cows in front of me, but you told me to go in uniform velocity. So I just, uniform acceleration, I bang them. Not possible. You have to slow down. And your direction will change. How can you move in straight line? Your direction, जहां direction change, वही velocity change, वही acceleration change हो गया. ठीक है? अब कुछ और interesting बातें, आ जाओ. So in grade 9, some more interesting thing. We have 2 topics now. Uniform acceleration means acceleration is uniform. Acha. I didn't say one part of acceleration, which let me complete that. Acceleration as a quantity is also a vector quantity, because it's daddy's vector. Na? Daddy is what? Daddy is velocity. Velocity over time. If velocity is vector, then acceleration is also vector. So acceleration also has a mag and has a direction. So do you see? The first father was displacement, vector. Uska beta, velocity, vector. Uska beta, acceleration, vector. All are vectors, right? All are vectors. Now, if you have uniform acceleration, that means if I draw a AT graph now tell me. Now the graph is a AT graph. On y-axis, I have got A, and on x-axis, I have got T. I am supposed to represent uniform acceleration. I'm taking a case, A equal to, say, 2 meters per second square. How should the graph look like? Uniform. Uniform. How should the graph look like? Yeah, Zoe, tell me.
Going upwards, but like equally.
Uniform. You take the value. Let's take our values here. This is 1 meter per second square. This is 2 meters per second square. How much did I give the value to you? 2 meters per second square.
So a horizontal line from 2 meters per second square.
So a horizontal line from 2 meters per second square. Exactly. It will be like this. Over time, it's uniform. It doesn't change. The color of your house's walls are uniform.
If it was non-uniform, then it would be upwards.
Yeah.
Sir,
This-
isn't that uniform velocity as well?
I didn't get you.
Sir, but like, isn't that uniform velocity too?
Okay, very nice question. Isn't that uniform velocity? I want these questions to come up. Thank you. Okay, and you should yourself then laugh on what you asked. Okay, if you want to make uniform velocity, then y-axis has to be v, and this has to be t. Apples with apples and oranges with oranges. I liked that question. Very good. Did you get it?
Yeah.
Uniform. So it has to be a VT graph. This is what graph, beta? This is a AT graph. This is a VT graph. What is this representing? Uniform velocity. Over the last 100 years, the velocity has been the same. Over the last 100 years, the acceleration has been the same. You get it? So can you tell me now on the same sense, if I tell you that I have got the grandfather graph, ST graph. Okay, S means displacement, mind you, huh? And I draw like this. Come, Sanvi, you will only answer this. What does this mean? Over the last 100 years, what?
It's the same displacement.
I have been at the same place.
Yeah.
Velocity 0. What is velocity? What is velocity? Delta S by delta T is what? Where will you measure delta S? Tell me, where will you measure delta S? Sir, delta S will be a vertical movement in this axis. There is no vertical movement. This, do you agree with me or not? This will give you delta S. Whether you're moving up or whether you're moving down, that's a different part. But in order to have delta S, the graph should move up and down. Pura kuch to change hona chahiye. Where will you measure delta V? Sir, here I will measure delta V. Where will you measure delta A? Sir, here I'll measure delta A. So if you are uniform velocity, then what do you say? You will say, sir, delta V to 0 hai. इसका मतलब क्या है? इसका मतलब sir, acceleration 0 है. Because my V1 and V2 are same. If delta V is 0, what is acceleration? Delta V by delta T. If delta V is 0, then acceleration is also 0. Right? Cruise, you're cruising on your car. Your velocity is constant. Your engine starts. You increase your speed. It will race down. Right? So we are talking about uniform acceleration out here. So tell me one thing. When you hear about delta S, this means what? Change in displacement. Okay. Pay attention here. Change in displacement. That means, don't you think there should be two values of displacement? Obviously, otherwise, how will you find the change? Sanvi has changed over the years. That means there are two different behavior patterns. What was once upon a time, what is now? Do you agree or not? So that means I should have a S1, I should have a S2. Agreed? If I have a delta V, that means what? Change in velocity. Change in velocity. That means I should have two velocities. Yes, we do have two velocities. We have a U and we have a V. Got it? However, in class 9, your acceleration will always be uniform. Please understand. Or constant. Means, will there be delta A? No, there won't be delta A. Ho hi nahi sakta. You show me one problem in class 9 if you have finished in school where you had two values of acceleration. You cannot have. That means you will have only one A. You won't have two A's. Correct? Now come to what I wrote. Did you learn this? Displacement. Did you learn this? Initial velocity. Did you learn this? Final velocity. But we don't have A1, A2 because we are in grade 9. So we only have one A. And another way to look at it is, since you have this fellow A, you have to have two velocities. Otherwise, A ho hi nahi sakta. Otherwise, A ho hi nahi sakta hai. You cannot have A. And you have T. Time. Many of you in schools must have done by now V equal to U plus AT, S equal to UT half AT, all this. These are all known as SUVAT equations. SUVAT. So they will say apply SUVAT. So whenever a problem comes to you, first see whether SUVAT is applicable or not. For SUVAT equations to be applicable, what should be? If a car is given to you, the car should be moving in a straight line. Then you are honoring this fellow. The car should have an acceleration or should not. They will give you an acceleration. Good. So you have honored this. They will give you acceleration. If they give you acceleration, I have told you in your years, the moment you hear about acceleration, you should think about two different speeds, a U and a V. Yes. And all these things will happen over a time. So, aa gaya na SUVAT. In such scenario, if they tell you that a projectile is launched in this manner, you know what is a projectile? You must have seen those Greek movies, Troy and all. Archers, they take the bows and arrows and start hitting the arrows on top. All the arrows go in this manner and then they fall. Is it a straight line motion? Projectiles are in class 11. Is it, you know what is a projectile? Now, what is projected? A tank fires a shell. So this is or Shaurya's favorite. Let's say Ronaldo has given a kick. The ball is moving in a projectile direction. Is it a straight line? Can you apply SUVAT? Straight away, no. Straight away, no. Many children without this knowledge will go in 11 and say, acha acha, kick na, initial itna, velocity final itna, time itna. No, 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 no. Ho hi nahi sakta hai. You cannot. Because body is not moving in straight line. So when we started teaching in grade 9, I told you something that we would like to change the name of the chapter. Now the time has come. So what should be the chapter like? Motion? No. We will say it.
Kinematics.
No. यही तो प्रॉब्लम है, जानता नहीं फिर भी बोले. Uniformly accelerated. Why I am saying your answer will come from SUVAT. Uniformly accelerated because there is only one acceleration. Uniformly accelerated motion in a straight line. Many books will have this chapter as motion in a straight line. बहुत books ऐसे लिखता है, motion in a straight line. Add this word also, uniformly accelerated motion. It's not non-uniformly. Means in class 9, we will have a A. Since we have a A, it will give birth to a U and a V and straight line. So we have a displacement and everything will happen over the beautiful thing called time. अब आप अपना सारा equation, so Dhriti, you learned all these things even say last year or before that, but now start marrying it. Why I used to tell you that there is a time for everything to learn. Now you marry everything of your things. V equal to U plus AT, yes, SUVAT. S equal to UT plus half AT square, SUVAT. V square equal to U square plus 2AS, SUVAT. I'll ask you one more question, though not from this chapter, chapter 3. If I drop anything from top to bottom, drop, I'm not saying I'm throwing, I'm just releasing, drop. Will a SUVAT equation be applicable here? Let us try.
No.
Why no?
Because there's non-uniform motion.
No.
Just think here. Is it a straight line?
Yes.
You answer me. Straight line, yes.
Depends. If there's a lot of wind going on, then maybe
Is
not.
there a uniform acceleration? Later you will learn on planet Earth, there is a uniform acceleration called G. It's constant. And the value of G is 9.8 meters per second square. This is constant. This is for Earth. So uniformly accelerated straight line. And since there is an acceleration, if I release Shaurya or Shreyas from a building top, the velocity here and the velocity here will be different. Na? जैसे नीचे आओगे जोर से नहीं गिरोगे, थट करके बस. Yes, you can apply SUVAT here. Sir, if I actually throw somebody upwards straight, will SUVAT be applicable? Oh yes, why not? Why not? Uniform acceleration, but this time the acceleration is acting opposite to my motion. My G is negative this time. I'm going against acceleration. Retardation. Imagine when you hit a ball upwards, when you throw a ball upwards, doesn't the ball slow down? Why does it slow down? Because acceleration is negative for you. Earth is pulling the ball downwards and you want to move upwards. Retardation. Classical example. Final velocity will ultimately become 0 at one point. And once it becomes 0, it starts coming down to us. It'll start coming down to us. So here also SUVAT will be applicable. This we will see in chapter number 3. So class 9 is all about SUVAT. SUVAT comes applicable only when you have straight line. That's the reason I took so much of time to come to this topic. And before we move to equations of motion, today is the last master revision. And tell me, are you fine with displacement? What all things can you tell about displacement? Let's quickly copy it down. Come on, everyone contribute. What all
The
things can you
shortest
tell
straight
about-
line distance from point A to
Vector quantity.
Okay, shortest straight line distance. Very good. What all things rest you can tell about? Come on, come
Vector
on.
quantity.
It's a vector quantity. So give an example that displacement can be 20 meters north. Yeah. Then what all you can say? Quick. Denoted by S.
Yeah.
Denoted by S. SI unit is meters. Anything else about displacement? और कुछ है? और कुछ नहीं है. I don't think anything else is there. Right? Let's come to the next tab. Velocity. Come on. Tell me all about velocity that you know.
It is also a vector quantity.
Okay. But before that,
Ratio of displacement
Distance
over
by
time.
time taken.
so I'm no more writing as displacement. I'm writing as S by T.
Over
Does
T.
that make sense to you all? It's S by T. Now I come to Shreyas's part that it is a vector because
It's a
its daddy is vector. Right? This is a vector. So give me an example. 5 meter per second at 30° east. Direction should be there. Okay. Velocity can be of two types. Initial velocity.
Final velocity.
Change in velocity will always be final minus initial. Always final minus initial. Don't go by the value. Don't try to get a positive value. Jaisa diya waisa aega. Anything else you want to say about velocity? You can also say that this is speed in a given direction. Means speed. You marry speed with direction, it becomes velocity. How do you change velocity? How do you change velocity? You can either change the speed or you can either change the direction. Neha goes 5 kilometers per hour north. Neha goes 5 kilometers per hour east. Both are two different velocities because their directions are different. Okay? Fine.
Yes.
Okay, let's move to the third person.
Sir, I have to go to the doctor. Can I leave?
Oh yeah, please go ahead.
Thank you.
Next is acceleration. Anyone would like to define? Oh, velocity. Okay. So acceleration. What is the denotion? A. A is given as
Rate of change of
V
velocity.
by T. Rate of change of velocity. V by T. Velocity. So this V is nothing but the change in velocity divided by time. What is change in velocity? Final minus initial divided by time. In fact, you will have done first equation of motion. Just see V minus U by T. If you expand this, what is it? AT is equal to V minus U or V is equal to U
U
plus.
plus 80.
वो जो रट्टू तोता की तरह रटते हो रटने का कोई जरूरत ही नहीं है ऐसे ये आ जाता है. This will do next class. Don't worry. Don't break your head here. Okay. So any other thing about acceleration you would like to say?
SI unit.
Okay. Yeah, it's vector. Its SI unit will be meter per second square. Written as ms minus 2. Anything else about acceleration you would like to say? Sir, acceleration can have two values, positive as well as negative. If it is positive, we in English call it acceleration. If it's negative, we in English call it retardation. Okay.
Or deceleration.
Yes, very good. I missed that word. Deceleration, deceleration. Acceleration, deceleration. Appreciation, depreciation. Just like that. Anything else you would like to say about acceleration? Sir, in grade 9, we would be learning only about uniform acceleration. That means in all our problems and all scenarios, we will only have A. We won't have A1, A2. We will never have A1, A2. Got it? And all these happens with their lovely little time pass partner called T. And now merge everyone. We have S, U, V, A, T. So to apply SUVAT, please check. Gaadi सीधा move करना चाहिए. And constant acceleration. Constant acceleration means velocity is changing. Acceleration means velocity is changing. No doubt about that. This will bring us now to the portion of equations of motion. And children, right now we have come to a stage where in our Lakshmi Singh, we are at that, I don't know, in my book, it is page number 19. There are a lot of, there's a question stage that we have come to. There will be some questions. You can try on your own, but I will do those questions before anyway moving, but you can try, please try. Don't close the book at home just because the class is over. See, I'll ask you a nice question. A particle is moving in a circular path of radius r. Okay, let's take one question. A particle is moving in a circular path of radius r. The radius is r. There is a particle. This is a particle. The particle is moving in a circular path of radius r. Displacement after half cycle would be, after half cycle. Tell me, what should be the displacement after half cycle? After half cycle means where should the particle come now?
So you asked this question.
No. That question was, here we are saying a particle is moving in a circular path. At that time, I was saying the wheel is moving on the road. There was a difference. That was a higher level question. This is a kilo level question. This is what was Shreyas was trying to say the other day. Rotating. Okay. This is the rotation case. So where if you rotate this wheel, tell me where after half a revolution where the particle will come. It will come here.
It
Yeah.
will be there.
So what is the displacement? I'll tell you what is the displacement, sir. The displacement is from here 2 pi r divided by 2. Get a big zero. Displacement is shortest straight line distance 2r. Shortest straight line distance between initial and final. Not pi r. Pi r karoge laddu milega. Pi r is distance traveled. Displacement is 2r. How many of you have understood? How many did not understand?
Understood.
To understand this one. Here it is like it is rotating. A particle is moving on a circular path. The question I gave you, a wheel moves on the road. Right? Did you understand why it became 2r? It is not 2 pi r by 2. 2 pi r means distance, the shorter distance. Numerical ratio of displacement to distance. See, that's why I say study this portion and try and answer. It is not so easy. Jitna easy aap samajh rahe utna easy nahi hai. Take your time, have your doubts, bring them up, because we are done with theory now. Now we will be getting into actual physics, and now you will start getting worksheets from me. The numericals now start. All these time that I have taken, and that's the reason I'm uploading them on YouTube, editing them and uploading, so that any class you have a doubt, go there and go and watch the video once again. Go and watch the video once again. But get your facts correct. Should you feel that there is still some doubt or I did not cover anything, go bring it up in the next class, right? So by next class, your concept about I'll not penalize you on graphs as of now. We'll do graphs separately, but you should, if I tell you what is uniform velocity, you should be able to understand. Uniform velocity means, sir, there cannot be a V1, V2. There can be only one V. Uniform acceleration, sir, we are grade 9 students. We'll always have one acceleration, A. And A means two V's are there. If there are no two V's, how can an A come? An A cannot come at all. Got it? Chalo. बहुत बोर हो गया है. Your faces tell that, sir, it's time for you to do GL. So sir will do GL now. And we meet up again at